All right, welcome back and welcome to lesson 9 in the Houdini Environment Beginner Series. We're going to continue where we left off and we're going to keep going with our house modeling, but this time we're going to I'm going to make this a little bit bigger so we can see the whole slide. We're actually going to take the base house shape that we ended with at the end of last lesson, lesson 8, and we're going to explore how we add a ridge and a dome to the roof, how we add some additional wooden blocks here, how we randomize some of these walls, which we did cover a little bit last time, and then how we pick some of those randomized walls and either add a door, which would be like a human-sized entrance door, or a garage door, which is just a similar door here, but a little bit bigger with some additional details. And then we're going to show how those work, and then a little bit actually on the grouping of setting those up to prepare for our Solaris layout and then surfacing in Solaris. So again, these little network maps here showcase where in the network we're going to be working. So we're going to jump straight up to where we left off in the last one and explore. Firstly, actually, I'll just show you how it goes through to the building. So let's reorganize. We're going to pick up from here where we left off in the last video, and then I'll walk you through again what's going on here as we split, and then we'll get started. So next up after this lesson, we had our measure area, which I did showcase a little bit here. But what we're doing now first is we're taking this whole house, we're creating this area attribute, and then we're using this all the way over here in these three sides. So for this roof, for the wooden framing, and for the base house shape, which is just essentially taking this exact same shape up here and carrying it all the way down to here. And then we're using that later in our actual model. So this house shape always comes through regardless of what the buildings are on each side. So that one's always there. And then we learned last time about how we split up the area and then randomize, and I'll show you again here, these different primitives. But since these first two boxes here only deal with the roof, we didn't need to know this random information about these walls. So that's why this branch comes from our measure and not from down here once we have that random attribute. So again, comes up all the way here, and we'll start with actually our wooden framing. So this setup, this little network box here, creates our wooden pieces on the outside, and it adds the shapes essentially to each of these different building tops. So how it works is we come in here, we get this full house. We're going to split with the extrude side, which is one of the groups we actually created up in here. I think it might be this extrusion, right here. We create a side group called extrude side. And if I rename this, actually, we'll try extrude side roof. And now when I go back here, we're going to see the split no longer works. And that's actually because we've renamed our group that we're splitting on. And this null I'm just using so it's an easy way to select and view the different inputs of our split node. So if we want to fix this, what we can do is we can type in extrude side roof, which is that new group we just renamed a second ago. And there we go. We have this side of our roof. And now what we want to do is we want to keep these long areas. So we only want to scatter our wooden planks along these longer areas of our roof, because we're going to make the assumption that, or not the assumption, we're going to imply that these roofs are somehow built to support the roof. These little panels are somehow modeled, maybe in whatever world we're here in our sci-fi scene. This is the construction they use for each house. So what we do is we get this side here. We split by measuring first our area. And actually we don't split, we blast. But we measure our area, which we've seen before. And again, if I want to see this, I can use our handy color node, ramp from attribute, and you see nothing shows up because we're actually on points. Our measurement is now creating a primitive attribute. So if I go primitive, area, I can now see with this color, visualize the area that our or Houdini is actually writing and saving to our primitives, which is again down here. I'm showing you all these attributes because I really want you to understand what's happening and then how we're actually managing and manipulating this data. So then what we do is we do a blast where we remove every area or every primitive that has an area less than 0.2. And this was just a value I picked based off looking off the spreadsheet to see, all right, well, I want to keep these big ones, but I don't want the small ones. And if we did want to keep the small ones for a different purpose, we could say delete non-selected and then maybe do something extra with these parts of the geometry. So we keep this area. We transform it actually down because I want just a center line, along the edge of this. And I'll actually show you two ways we can get this line. But one way we can do it is with the transform with an expression here, a new one we haven't seen yet, which is CEX, CEY, and CEZ, which is the centroid of the input geometry. So if I wanted to scale this to 0, we could see what happens is it scales it to 0, but it bases the pivot transform off 0, 0, 0, the origin of this world. But what we want to do is we want to transform this pivot to the center of this object's bounding box. And one way we can do that is with a pivot translate of $CEX, which is an expression for X, Y for Y, and Z for Z. So CEX for X, CEY for Y, and CEZ for Z. And then if I scale this down, you can see our pivot is now oriented, or our pivot is actually placed right at the center here. And we actually don't need the X and the Z for this case because we're not scaling an X and Z. And then if we did actually scale an X and Z, we also wouldn't need it in this case because our X and our Z are actually already centered at 0 and at 0. So Y, since it's not at 0, it's elevated here above our world origin of 0, 0, 0. We wanted to have that expression here. And I just middle mouse button, you can also drag to add stuff, but I'm going to delete that as well. So that's one way we could create this line, which is by scaling these down. And now you'll notice there's actually 2 points. So what I first do is I fuse, or I resample to add more points, then I add, delete the primitives, and then I fuse. What I could also do is fuse before, which looks like it didn't work, so we'll just leave it as what it was before. So I wanted to merge these down, I wanted to add extra points in between, and then I wanted to merge the points that are near each other, which I used to fuse for. The other way we could actually create this, I'm going to delete this transform, is we could do a Boolean and we could cut. We could say, all right, place a giant plane exactly where this object is, cut it along the middle, and then only keep the seam of that cutting surface. So the way we could do that is with a grid. And I'll show you just a few ways because there's always a few ways we can do things in Houdini. We're going to put 2 rows and 2 columns, and we're going to make this grid really big. So 50-50, because we know that 100% of the time this grid is going to be bigger than our input geometry. And then what we're going to do is we're going to Boolean. We're going to take this incoming geometry and we're going to combine it with our grid. And now what's actually happening is nothing because we're cutting a solid, actually a surface with a surface, but Houdini is expecting a solid and a solid. So we're going to say surface and surface. And now what we're going to do is we're going to set it from subtract to seam. Which should work. Okay, whoops. You see, I just made that mistake, so we're gonna fix this. I was thinking a little farther ahead, and the reason this actually isn't working is because they're not actually intersecting. So I did skip one step, which was going to be placing this actual grid where it interlines, where it lines up with this geometry to cut. So the way I'm going to choose to do that is with a match size. So I want to move this geometry, and I want to match it with the position of this right geometry. And then I connected this to our Boolean, and there we go. So without this match size, it wouldn't give us the proper cut. And then if I set it to surface, surface, and where I generate seam, you can now see that we've created a seam here that aligns exactly between these two objects. In this sense, we've actually cut a seam. There is no duplicate here for the primitives, so we could wire this version here actually straight into a resample to give extra detail, and then we could take this resample straight into our normal. So the only reason we needed this fuse was because when we transformed this down as 0, these 2 points here were going to be placed on top of each other, and we wanted to use the fuse to merge those 2 points together to create a single point. So then when we copy down here, we're not copying duplicate boxes. So I will disable these and then arrange this so it's a little easier to see. So then again, we have our area coming in here. We place a grid, a really big grid. We align that grid to where we want to cut our geometry in. We actually cut with our Boolean, set to surface, surface, and seam to give that nice cut. If I hide that template flag, we can see exactly what's going on. We resample to add those extra points. We create normals from this object here. And the reason we need those normals is so it aligns to the outside of this object. And these normals we're actually transferring, which might actually be a new node we haven't covered before. So what an attribute transfer does is it takes an input geometry here, which I'll do a new one actually. So I can delete this and then I'll reset this here ourselves. It takes this input geometry. We want to add normals to the points. And then we want to use this newly computed normal and we want to add that to this geometry here. So this left input stream here does not have a normal attribute. And we're going to transfer it from this side using an attribute transfer. And now it's taking normals from the points and copying it from this right side to this left side. And the way it's copying that is by this distance threshold here. So we're just going to leave that at default. But that and then the blend width will actually blend between it'll be the different way of transferring its attributes. So we'll use these a lot in Houdini, but for our purpose now, this is all we did. And the reason we did that was to orient these boxes along those normals. And then again, space G to frame this box. That's the positive Z. Space G to frame the copied points. And there we go. And then I colored those to make them look a little bit like wood. And then down here, we add a building wood group. I'm going to hide that template flag. And then that is merged in later. So then I'm going to mark this as black to say we've already gone through it. And then again, the reason these nodes are so far apart is just because that was the best way to organize the scene file. As you work, you might want them closer together, so you have to pan a little bit less, which is a perfectly fine way of working. All right, so next up, let's look at, we just covered these blocks. Let's look at the ridge, dome, and the roof. So starting in here, what we're going to do is we're going to try to take the top of this roof with, again, a group by normals. And we just want the top here. And we want the big piece, so the way we're going to get the big piece is by actually measuring the area of this piece up here. And we're going to measure the area on the primitive side. And then we're going to remove primitives with an area less than 3. So we can look at our geometry spreadsheet here. We can sort and we can see this big piece has an area of 43. And the small ones are a lot smaller than 43. And the reason there's so many pieces is because each of these little cuts is its own primitive. So there's a bunch of these pieces, but we just want this big one. And there's actually another way we can do this. there's labs, side effects labs has a delete small parts, which lets you extract the largest piece in a geometry. So this here, done with the measure and blast, does the same thing as this node, which just gives you the biggest piece in an input stream. So that's why side effects labs is sometimes so helpful. There's extra tools that do save you a lot of time. All right, well, next up, what we want to do is we'll explore this left side actually. It looks like this creates this extra ridge. So what we do a poly extrude to get this inset, this side face. And then we do another one here. So an inset with the positive value here, and then an inset with the positive value again. And we just want the side here. So we want to get this little ridge that is inset a little bit, but also has some width for us to then extrude up, which we then do here with another poly extrude. And then that is then merged down into our merge to get this little ridge on the roof. And then this part actually in the middle, it's randomized a little bit. So we get a split between a sphere, a little half dome on top, or this external shape here, which actually is this shape right here. So we have created a new, and I'll color it really quick. These 4 nodes, these blue nodes here, are what define the shape of that object. And then this sphere is what defines the shape of the other object. So to go through this one, we get our object coming in here, and we're assigning it a random value. So for here, for this primitive, we're assigning this the random number. In this case, it's 0.391642. And we're saying, all right, if this random value is less than 0.5, so a 50% chance, we want it to be a patio, which patio was this side here on the right. And if it's a different size, so if it's greater than 0.5, that code is going to say, all right, if it's less than 0.5, do this. Else, so if it's greater than 0.5, because that's the only other case here, then we want to assign it to group dome. And this with the group underscore is how you assign a group using Vex. So now if I click here, we see patio and we see dome. And you will notice actually it's group underscore dome. So if I did this equals at group underscore, actually I'll show you in a new wrangle because this is helpful to know how to do. We'll say we're going to assign everything here a group, and we're going to name it my super group. So we're going to say I at group equals, or I at group underscore my super group equals 1. Now what this is doing is saying, all right, create a new group, my super group, and assign all these points inside this whole wrangle a positive values for being in this group. So it's true. So it is in this group. Now if I blast and say delete my super group, it will delete everything. And that's because everything is currently in this group. If we wanted to only maybe delete the positive values, so maybe we'll say if its x coordinate is greater than 0, we'll delete that. So the way we can do that is by doing a conditional statement with an if statement. So if v at p, if position dot x is greater than 0, then I want to do something. What I want to do is if it's greater than x, or if x is greater than 0, put it in my supergroup. And there we go. Now we see this is assigning these objects, these points, since we're running over points here, assigning these points a Boolean value of true. So a 1 is a true value. So correctly, yes, you are in this group. And then we're deleting all the points that are in that group. And actually it looks like I misspoke. This is less than x. So it's keeping the positive ones by deleting the negative ones. If I hit delete non-selected, it'll do the other ones. And then the reason we're not getting it cut in the middle is because there's no points here in the middle. So when these points are all deleted, this is the only other point that has a primitive. So I'm going to delete that, and that's a quick tip on setting that up. And then we'll keep going. So again, that random function split here. I'm going to delete those two. And then what I want to do is I want to decrease the size, it looks like, of this piece, and I want to get a little bit of a bound. Because when I copy my sphere, I only want it to be a small size of the sphere, and I don't want it to go too big because I want it to fit inside this roof. The way I've done that is I take the bound and then I add a minimum padding on the lower and the upper sides of X and of Z. And I don't do Y because this is only a flat plane, so Y wouldn't necessarily have any use case. And then it looks like I delete points with a positive value. And the reason for that is this bound is actually giving me a box technically. So bound does a bounding box on an object. And since the incoming geometry is a flat object with no Y, it's exactly 0 on Y, it gives me a bound, but there's two faces. And you can kind of see this normal fighting here. And if I look at points, you can see there's 2 points here. So what I want to do is I only want to keep this top face. And the way I decide to only keep that top face is I delete by normals. And I delete normals, so operation delete non-selected that are not facing upwards. So that then goes from 8 points to 4 points. So it deletes that bottom face. And then what I do is I extrude that up. I actually extrude that really tall. And the reason for that is so my sphere has a nice object to match. So I place this big box back to the center of where our roof was with a match by size or match size. And then I place our sphere to our roof area here with a scale to fit. So I can scale it up as big as it gets. And the cool thing about this is that the sphere is, say, maybe super big. When I do that match size, it will automatically scale it down to the correct size if I hit scale to fit. So space G. And then there we go. And then I use this poly extrude again as a Boolean to clip, so I only keep the top half of our sphere, because we don't necessarily need anything inside the building. And then that is merged down here. And this side of this graph only runs when the value is less than 5. So sometimes on random frames, we might get no sphere. So here, this will be an empty stream with no geometry here on some of them. And that's because on those frames, Houdini is splitting up here and putting that geometry, and it's assigning it to this right side of the split. And then this right side of the split is where I set up the other patio area of the roof. And the way I do that, again with the bound, to shrink it a little bit. And that's so this shape that I'm copying there doesn't quite touch the edges of this. So if I remove this bound, you'll see it goes too big and it fits the edges here, but I wanted it to not intersect this ridge. And I fixed that issue by adding a bound with a negative padding. And then again, the bound gives us a upwards and a downward facing object because it is creating a box. And you can see that normal fighting again. We keep only the upward facing face, only upward facing primitive by normal. We extrude it up, so same workflow. We match it, so we put it back to where the roof was. And then we create our box. And then for grouping this, I just scaled down the top and did a little transform to make a shape. But you could do actually whatever you want. You could do test geometry even. And you can match that here. So if you wanted to put some other kind of geometry on top of your object, you could do that. Which case would give us this. But I chose to do a nice little box. And on this left side, I chose to do a sphere. But you could extend this to add maybe a second story, or maybe some of these other nodes you could copy and paste and see if you could figure out how to get a second floor on top, maybe with extra windows. Awesome, so we'll keep going. That's the end of the roof, and then we do add another group here, stone, which we'll then use later to actually color and prepare the name attributes for Solaris. Then again, as we play through, we see all this randomization taking place. All right, well, let's keep going. We're going to go into the human-sized door next. And then this side, we're actually splitting in from here. So remember this part, we wanted to randomize the primitive numbers on each of these faces, each of these primitives. And the reason we wanted to randomize those is because we want each frame number to have a different probability of getting assigned a door or a garage door. Technically not a different probability, since the probability is always the same. We just want different faces, different primitives to get different parts on each variation C that we create. So for this one, this incoming object is being split again. These are all sorted. I split, say, okay, only keep primitive 0. Move that primitive 0 over here. And now here, we're going to create our door. And at the bottom, we'll have our finished door, which will actually merge in with the rest of our objects. The way we create this door is first we get this incoming face, this incoming primitive. I create some normals on it. And then what I want to do is I want to define a door size, and I want to cut a door size out of this object. And the way I've done that is I manually set how big I want my door. So maybe it's 1.4. Maybe this door is going to be a little bit shorter, so we'll make it 2 units tall. And maybe this will be a 1.4 as well. We'll match that and place that here exactly in the center of this door. And we could even offset this if we wanted. But for now, we'll leave it exactly in the middle. We group the top of this door. And then what we're going to do with this group actually is we want a little round edge. So we're going to add a round edge only to that up group. And we do that with a polybevel set to group, or set to bevel only the upwards group. Now you can see we're adding that little extra detail only on the up side of the group. We then create some normals for our Boolean, and then we Boolean that together actually with a slightly different version. So in order to get this width for the door, I need to have this shape here, this beveled shape, and then I need a shape slightly bigger than this. And the way I fix that issue is I peak. Again, I displace these points slightly along their normals. And you can see those normals are a little difficult to see. We peak them out to add a width to the door, which now we've selected as 0.4. We can make this 0.3 even, or however wide we want it. We bevel that up because that's always saved from this group here. We peak it just a little bit more. Add normals for the Boolean, and then we cut. And then we combine this plane here, and we cut from this object as well to give a new width. And for this one, we have it set to intersect. And then for this one, also we have it set to subtract. So that's the other thing. This object here we're cutting is a surface. That's coming in the left side of the Boolean, which is A. So we want that set to surface. And then since the right side is a solid, we want that set to solid. And then here from this null, from this Boolean, we're outputting a surface as well. So in the next Boolean here, we want it set to surface. And then since we're booleaning a surface with a solid, we want the B on our Boolean, set B, set to solid. And the operation we're doing is subtract. So take this surface and subtract this solid. And that gives us this. And then this actually what I wanted to do was I wanted to take this object and I want to displace it a little bit, but I want to displace it along the normals, but I don't want it to go up on Y. So the way I chose to fix that was, and I'll show you the issue now. So if I displace this here with the peak, it'll go towards its normals direction, but this will slightly lift it off the base of the 0. So Y, it'll slightly get higher and higher. And the reason I wanted to have that fixed, because I want it to be cut and set flat to the ground every time. So there's a few ways I could do that. I could either displace it and then manually set Y back to what it was using a wrangle. But I actually set a little snippet of Vex here that rounds the normals. And you can see they're going from points to vertices. And actually what I could do is I'll recompute these for points so we can see it a little bit better. So Houdini's taking these green normals, which are on the vertices, and it's automatically moving them to points, but to be consistent, I will manually set these points, set these normals on the points, and then I round these to the nearest integer. So that's saying if it's very, very, very close to 1, I want you to round that to exactly 1. Now if it's very close to 0, I want you to round that to 0, and then if it's anywhere in between, it'll round to the nearest 1. And then I peek that, which will place it along only that. And you see now it's not going up and down on the Y. It's only going directly in the X for this option. And the reason I didn't just displace them only along the X is because we're randomizing each of these walls up here, I'm not sure whether, you see right now we're pointing in the negative X. Right now we're pointing in the positive X. Right now we're pointing in the negative Z. And don't actually worry about this, we'll fix this later. Actually fix later down the line. But these, I'm not knowing the incoming direction and orientation of these objects. So I wanted to have a set of nodes that was not dependent on whether they're facing in the X, positive, negative, or Z, positive or negative. So I'll put this back to negative 0.2, maybe it was. I extrude it. And now the reason actually what we're doing here we're moving it here, but now you'll see what Houdini does is Houdini doesn't use these normals because these normals are not technically the correct normals that Houdini is expecting. So it displaces them in a different direction than the normals. So see, normals are facing correctly in this one direction, and this is being displaced slightly upwards. So the way to fix this is on our poly extrude for extrusion mode, I want to set it to point normal, and instead of pre-compute, I want to set it to existing. And now it'll read whatever normal attribute is saved on the object, and it will displace it in that direction. I could also set it to attribute if for some reason I had a vector that was named maybe velocity. I want to extrude along the velocity, or maybe some kind of arbitrary vector I created. This is existing, means it's reading the N attribute, and attribute means you can set any name here. And this doesn't actually work because it's not set to my attribute. So I extrude that, recompute again the normals, and then I color this. It looks like white, but I can really color that whatever I wanted. And then there we go. And that was the outside of the frame. And now for the inside of the frame, I follow up again here. And I actually want to take this inside cut that we just had. And what I want to do is remember all this stuff we just covered before. We did this bevel, this peak, and this peak. And then what we're going to do is we're going to take this original wall here, and we're going to cut it with this smaller side of our object, which is this Boolean here. And we're going to cut the surface with a solid. And then we do the same trick with rounding normals to peak, and we push it a little bit away in the direction of their normals. You see? And then we extrude again with the attribute set to manually selecting the attribute, so it allows us to displace in the manual normals we've set here. And then extrude again, and this time I actually do an inset. So I want this little door to have extrusion, a depth, and then a little ridge, and then I want it to be extruded back inwards. And then I do that with a negative extrusion set back to extrude front, which is the group I created here. And then these are normal artifacts in our shading, so that's fixed by a normal node, which is why it's also important to know kind of what's going on with normals, as normals are important in shading. And if you modify them for modeling, you want to make sure you have correct normals when you are starting to prepare for shading. And I add a color. I group it as building metal door, which again we'll actually use in reference later here when we name it for our Solaris importing. Merge those together, and then again for good practice and normal. And it looks like this actually messed it up. So we will see if we can fix this. vertices, vertices. All right, looks like that got issued. The issue, excuse me, got fixed. All right, well, we'll disable that normal. I'm gonna add a null here. Sometimes with Booleans, you get a little artifacts, and it looks like that artifact is coming back. So let's see what we can do to get it fixed. So space G to frame. We're gonna work up this graph and try to figure out where that artifact is. See what happens if I do this on the peak. All right, I'm actually going to pause it real quick and see if I can figure out where exactly this was, so we're just not wasting time, and then I will come back to let you know where the issue was. All right, welcome back. Turns out that was a little bit of a weird issue, which is why sometimes Booleans are a little bit finicky. But the issue ended up actually being solved, not by me changing anything. I actually did try to place a clean node after the Boolean, which was causing the issue, to see if that would resolve it. And it did, and then for some reason I went back and it didn't again. So the way I actually fixed this was when I had the Boolean issue, I just opened up my new viewer, scene view. I closed out of my old one, space G, and then I will pin this again back to 1 so it fits. But it looks like just resetting the scene view fixed that issue. But in my experience, sometimes when those issues are here, you can either try to fix them or just ignore them and then see if they go away later. Like I did have that actually while preparing these scene files, and then they were actually fixed later when I do a poly bevel. And then if I do a VDB remesh, that might even fix them as well. So even though you do have an issue, you might not need to have a solution to the issue, because maybe somewhere along the rest of the network that actually does get fixed. So we'll just keep going. But I do encourage you, if something's not working, maybe restart Houdini, try a clean node, try to manually set the normals, and then go node by node to see where the issue first comes up, and then maybe break off and branch off to see kind of what things you can do to fix the issue. So again, this side here, we have our normals, we peek it, extrude. This was creating that door with the inset. And then we add the color, group that, and then that is the end of our door. If I can correctly, set our merge down here. And there we go. All right, so we'll go on the next part, the last part actually of this part. Whoops, excuse me. The last part of this lesson video, we're actually going to set up the garage door, which is done in a very similar way, but it is done with a slightly bit bigger of a door, and then I actually added a few more little extra things to make the ridges here at the bottom, which you can see if you zoom in. So very similar to that human door, we get our input shape, our primitive, which is randomized on every frame. We calculate normals for our Boolean to prepare for that. Then we get a bound. We scale down the bound. So now we're deciding how big we want our garage door. I match size to fit that back to where the garage door is. I measure the area. So now what I want to do is I want to find these big pieces and not these thin walls. Whoops. O again shows this little map, and then P will show and hide a parameter pane, just in case you accidentally have those come up. So what I'm going to do is I'm going to measure the color, or I'm going to show measure the area attribute with a color node. So I'm going to take this color, go to primitive, go to ramp from attribute, and set to area. And now what I want to see is I want to see the areas of objects that are bigger than 10, and I want those to be white. So maybe 5, and I'll drag the black here. And now you'll see I can even change this from black to red, and these small areas are red and the bigger ones are white. And I use this area to group based on if area is greater than 3, and then I then peek these objects, these faces, these primitives, in the direction of their normals. And I do an opposite direction actually to make it thinner for the inside wall of the garage door. And then the reason again that I'm measuring the area instead of just displacing maybe in the Z or the X is because every once in a while, you can see here, our garage door is either facing in the Z and the X and the negative X or negative Z. So there's lots of different ways that the door can be facing. And then we want to make sure that we're always getting the correct size of the door and we're displacing the correct part of the door. And one more thing actually, which is something we actually need to take care of here. We are making the assumption that only one door will ever be a garage door. So if we watch through this timeline, we'll never have two garage doors in the same frame. And the reason for that is because we always split by an exact primitive number. So we're not assigning random chances like we do later. We always say, okay, take primitive 0, or I guess primitive 1, and make that a garage door. So we're never going to have two garage doors, so we never have to worry about extruding multiple doors into multiple directions. So we are going to keep going here. So we group those large areas, we peak them, we group the top, it looks like only the top, bevel the top again to make that little round area, similar to how we saw in this last door. We're going to peak that to make it a little bit bigger, create normals for our Boolean, and then Boolean that with the original incoming shape for the garage door. And actually the reason I did this peak was because if I don't have this peak, the Boolean, the bottom of this base, aligns actually exactly on the same y coordinate as the incoming plane or incoming surface. So I wanted to peak it so it was pushed down a little bit below the base of this wall, which just lets us get a clean Boolean. You see, without that peak, we get a little bit of a intersection artifact. So adding this peak did fix that by ensuring that it was never intersecting the exact bottom of this cutting surface. And perhaps this was the issue we had earlier, so that's just a good thing to kind of keep aware of as you're working with Booleans. Then I do that same trick where I round our normals, and that is with the function rint, which rounds the number to the closest whole number. And then I'm using n.x, y, and z to get the x, y, and z values of our normal vector. So x, y, and z. And I extrude along the normal. Again, same trick we saw. We had to do a poly extrude. Set to point normal, set to existing. And now we can extrude along that manual normal we set here with our rounding. You see, by disabling this, we're now extruding in a different normal direction, but we wanted to keep it flat along the y, so it's always touching the ground, and that's how we solved that issue here. So delete, extrude, normals again to fix this little shading error, and then stone. And then one more thing actually on some objects, and I do want to show you this because sometimes it's important, on some codes like here on a wrangle, if we want to know what's going on with our normals, sometimes when you displace an object's position, there will be inside the wrangle or inside the node a update normals if displaced. So sometimes you might displace an object, you might not intentionally want to modify the normals, but Houdini might assume you do. So always make sure you're knowing whether your normals are being updated or not, and sometimes that is a setting on most nodes, whether it's update normals if displaced. I think Mountain also has that, and a few other nodes to be kind of aware of. So here we get this inset area here, which we're actually going to use to create the main geometry of our garage door, which again was just peaked from here, made it thin to make it a little bit smaller, and then we do a Boolean with that round side that we created up here. Add some normals, and then what we're going to do is we're going to add these little ridges here. And the way I chose to add those ridges was I wanted to take this incoming object, I want to take only the bottom area. So I want to delete everything but the bottom. And then I want to extrude this to add some thickness. You see, we add a poly extrude with output front and back. I'm going to make it a little bit bigger, so then it extrudes past the edge of our geometry for our garage door. And then I want to copy this 3 times upwards. So I do a copy and transform of 3 times upwards, and I set the translate to 0.2. So I can make this maybe we'll do 5 actually, just to practice. And then normals again to update these shading artifacts. And then I do a match size with a offset on the Y, because I want these a little bit elevated from touching the ground, and I want them elevated by 0.3 units. Then merge those together. And then because this door is not in the center of the little extrusion area we made, I just want to match its size to fit the exact spot. So without that little match size node, our door would be too far back on the inside of the actual house. But I want it right in the center of the area here, and I do that with a match size. And then this color was just used for internally, so just so I can see in the viewport or in the scene view which one each object is, and then it lets me get a little bit of a sense of what the materials are actually going to look like once I start adding them. And then garage door, and we merge that down. And then you actually can see we do assign those groups here that we're going to split out later for shading. So C to hit color, we'll color that black because we've gone through that whole one. And now at the base, you can see we've added this small area here. We've done this roof here. We've also done this side here. So two out of three actually areas of this house we've already covered. So that will be it for this lesson. And then we're going to jump into the next lesson where we're actually going to explore, looks like some windows. So we're going to explore this area of the graph, our first for each loop for this one, which will actually be really cool. And then we're going to keep going and slowly understand more and more of this network. So awesome. I will see you in the next one, and we'll keep going. So thank you and have a good one.